entitle this binomial distributions. Again, this is just a title here. You can title your notes that. Just going down through this is what we're going to cover this section. Determine if a probability is a binomial. Find binomial probabilities using a binomial probability formula. You're going to love that. Find it using technology. Yeah, maybe not. Ebersole's sort of in a bad mood. Graph a binomial distribution. The graphs are going to be the same. Still making a histogram. And the very last thing that we got to make sure that we get to, be able to find the mean, variance, and standard deviation. There's special formulas for each of those that makes everything a little easier than doing that big long chart. And it makes it easier than even using your calculator to do it. Oops, sorry. A binomial experiment. So again, just binomial distributions, what this is titled. Binomial experiments, probability experiment where results can be reduced to this. Key thing here for the whole day. To be a binomial, two outcomes. Success, failure. That's what makes something a binomial probability distribution or binomial probability instead of just anything. As a success, failure. You can whittle it all down to either it's a success or it's a failure. That's where binomial comes from. Bi means what? Two. So you got two possible outcomes. That's it. Not three, not four, not five. Two possible outcomes. Either it's a win or it's a loss, or a success or a failure. To be a binomial, I'm not sure why this shouldn't binomial experiments. Let's get rid of that and just write to be a binomial, and I'm going to try to shorten these up a little bit before I get out of the way. To be a binomial, number one, fixed number of trials, and each trial is independent. Number two, only two possible outcomes. And those are success and failure. Number three, probability for all, can't write, for all is the same. And number four, all you really need on number four here is the X stands for successes. Now you got to be careful with that because there'll probably be problems where they say, if the patient dies, consider that a success. Or find the probability of if the patient dies. Well, that's not really a success if they die, right? So it's sort of turning it around. But those four things is what makes something a binomial. Certain number of trials, you might have 10 trials, 100 trials, whatever it is. Each trial's got to be independent. Number two, there's only successes and failures, nothing else. I didn't do that. Number three, probability of each trial is always the same. So if the probability of the first trial is 1 out of 5, the probability of every other trial has to be 1 out of 5. And then number 4, the X, we're just using the X to be the number of successful trials, or how many successes we're looking for. That's what makes something a binomial distribution instead of just any of the other distributions that we've been talking about. Next thing, these here are important. These are the 4 things you're going to be looking for. Again, N just stands for number of trials. P is your probability of a success. Q is probability of a failure. How do you find Q if you know the probability of a success? So 1 minus P, you might write that down for Q right there. And then X is just the number of successes that we're looking for. So maybe you're looking at 3 successes out of the 100, or 5 successes out of the 100, or whatever. But those are the 4 things, N, P, Q, and X, that you got to find. They're not real difficult, but you have to find them for each binomial. So every time you start one of these binomial problems, those are the 4 things you look for. N is the total number. That's what we've been dealing with all year long, the total number in our whatever it is that we're dealing with. P is the probability that you have a successful outcome. Q is the probability you have a failure as an outcome, and X is how many successes you're looking at, whether you're trying to get 2 out of the 10, 3 out of the 10, 4 out of the 10, 5 out of the 10, whatever. So if we are talking about Gage shooting free throws, then we're probably looking for like 1 out of 10 or something, and saying, all right, what's the chance that Gage is going to make one of these?
That's reasonable. Was it 2%? 5%. That would definitely be a probability of failure question.
Yeah.
Gage, so what's your
And
prediction?
then if we said something like, what's the probability that he makes 4 out of 10, we know that the probability would be extremely low. Decide whether each experiment's a binomial experiment. If it is, specify N, P, and Q. We're going to just do this together. List all the possible values for the random variable X. So this will show you what you're going to do. A certain surgical procedure has an 85% chance of a success. Yeah, do that before. That's what I wanted to do, is just flip it for me so I can sort of look, because I wrote stuff down in case I forget to say something. A doctor performs a procedure on 8 patients. The random variable N represents the number of success. The random number variable represents the number of successes for the surgeries. What's our N? How many surgeries is this guy performing, or this person performing, I should say? 8. P, what's our probability that it's a success?
85%.
Now, when we write this, we got to write it as a decimal. So 0.85. Q, we just subtract this. That's just a chance it's a failure. So 0.15. And then our X, the different X's that we could have, how many successes could he have?
8, 7.
that it?
0.
That's what we gotta find each time when we start these problems. What we're gonna do with that, we're gonna make our chart, and you're gonna have 0 through 8 listed, and then find the probability of each one. And then what they're gonna say is, okay, what's the probability that 3 or more were successful? Well, if we have the chart over here, all we gotta do is add from 3 down to find the probability that 3, 4, 5, 6, 7, or 8 were successful. So we just did all that. That's all what we had right there. Could also use a tree diagram. Thought I had a tree diagram on the next one, and must be on one of the others. So you could also use a tree diagram to figure out all this stuff. I don't like tree diagrams, they're too hard to draw and take up too much space. Decide whether the experiment's a binomial, same thing. A jar contains 5 red marbles, 9 blue marbles, and 6 green marbles. You randomly select 3 marbles from a jar without replacing the marble. The random variable represents the number of red marbles.
This isn't binomial.
Is this a binomial? Why not?
There's not a win-loss thing.
Now, there is sort of a win-loss. What's our win?
Red.
If we get red. We lose if we get
Blue or green?
blue or green, right? But the bad thing is,
You don't put them back.
you don't put it back. So, let's see, what is there? 5 red, 9 blue, and 6 green, that's what, 20? So what's the probability we get a red on the first marble? 5 out of 20. If we don't replace it, what's the probability we get a red on the second marble? 4 out of 19. Are those two probabilities the same? So it's not a binomial. Since those two aren't the same, it's not a binomial distribution.
But if you replace it,
If you replace it, then you could make it a binomial. And that's, with binomials, binomials are going to be easier than the other stuff that we've been doing. So even if there is red, blue, green, yellow, purple, so on, if we can simplify it down to just successes or failures, like if we want a red and we don't care what any of the rest of them are, red's a success, everything else is a failure, then it could still be a binomial. This is the binomial formula. I don't know that I'd write anything else down here except for this right here and this formula. This is just the formula that we had when we were talking about combinations. It's just showing you that it's the same thing up there. Give you a second. Make sure you write it carefully. Oh, the other thing I should say, here, where it has X's in here, those were the R's when we were doing combinations before. Let's put water on. Not getting another job yet. Trying. Thought it was a butterscotch, it was a lemon.
Sounds like I am.
So when we use this formula, all we're gonna do, everywhere we see N, P, Q, X, we find them all right at the beginning of the problem, we just stick them in there. then we use our calculator to calculate the probability that that X number of successes comes out for that certain event, whatever it is. Now, for most of these that we do, it's not gonna be real long. If it's real long, then there's ways you can use the calculator to do it all, but it's still a pain in the butt. So we find each one. I mean, you're gonna have to use your calculator regardless, but you find each one and you make our little chart, our probability distribution. This is probably the part of the formula, because we're gonna use our calculators. That's the formula that we're gonna use probably. Just let our calculator do the work for us instead of working out the combinations longhand. Microfracture knee surgery has 75% chance of successes. I don't need it. I mean, I know what I just need to see that, what I'm gonna do on it. On patients with degenerative knees, I gotta start making these easier words to read. The surgery is performed on 3 patients. Find the probability of the surgery being a success on exactly 2 patients. So we go through each problem this way. What's our N this time? What's our P? 0.75. Have your calculators out so you can help me here in a second. What's our Q? 0.25. And the other thing we need is our X. That's what we're looking at. That's the successes that we want. How many successes do we want this time? And it's exactly 2, so that makes it sort of easy. All we're going to do on our calculators, I got C here, N goes in front, so 3 in front, X goes behind, then P, what's P this time? So 0.75, and you raise it to the X power, right? I think that's what the formula said. And then you're going to times that by Q, which is 0.25, raised to the N minus X power. And usually I try to do some of this, a little bit of this in my head, like here, it's not too hard. What's N minus X?
Do you gotta use any parentheses?
No. Now, what I'll tell you to do on your calculator, I would do this part first, and then hit equals. Because then the number's going to be right there on your calculator. Because I don't know how the calculator is going to, if it'll understand it all. You might figure it out and it might do fine, who knows. That's up to you. I would do this first, hit equals, and then all you're going to do is once you have that number, once you have that answer, just hit times 0.75 squared times 0.25. And then hit equals again, and it'll do it for you.
I got the same thing.
Got it same
Yeah.
either way?
Yeah, 40.
So you got the same, what'd you do? Did you put parentheses around anything or anything? You just typed
Just
in
straight like that, yeah.
3C2.
Yeah.
See what I'd be, I guess if you hit times there, well, see, what I was worried about is it's gonna take, the calculator's gonna take the 2 times the 0.75, but it didn't. Alright, so if you guys don't it works that way for your calculator, then whatever. What'd you come out to?
0.42.
0.4,
2.
what's after that?
1.
What's after that?
8.75.
It's about, we'll go out 3 places probably. So 0.422, so that's about 42% of the time this doctor's gonna perform this surgery, and 2 out of the 3 are gonna be successes.
That's not a very nice.
Yeah, well,
that's not counting 3 out of 3.
Exactly, so you're not,
It's not counting.
it's not counting the 3 out of 3,
That's only,
so that's only if it's exactly 2, so that means there's 2 successes and
So he's.
one failure.
So he's better off not failing.
So let's do this.
Get three-
What's this saying?
It's 3 taken.
3 successes, right? Now you gotta be careful when we plug in the rest of this. It's 0.75 to the, what is it, to the x, right? So that'd be to the third times, what's, if our x is 3 now, what's 3 minus 3?
0.
What is 0.25 to the 0 power? 1, so do we really need that on there?
No.
Oh, it's the same percent.
It's the same as this one?
It's getting all 3.
So that's 0.422. Now, how would we find the probability that this doctor's gonna, at least 2 of the surgeries are gonna be successful? What would we do with those 2? Add them together. So if we said at least 2, we add them together and we get 0.844. So about what percent of the time does he have 2 or 3 successful surgeries in that day? About 84%. Seems a little better, right? But remember with this first one, we were just looking at exactly 2. We could have made a tree diagram like this. All right, you got success, failure. Well, if the first one was a success, he could add another success or a failure, and so on, and then I listed them out right here. 3 successes is, I can't read that, what's that say? 20 what? 22 out of 64 times he's gonna,
27.
That's 27.
it's 27.
Yeah, you know, I never
lose right too. No,
Yeah, that's 27.
The one in front of it's a 2.
And anyways, it's 3 times 3 times 3.
I can't see none of that.
I wasn't reading that. I was looking
So,
at
just list them all out here.
Gosh, Gage.
3 successes, 2 successes, 1, 2 successes, 1, 1, 0. If all we were asking on this problem is for the 2 success ones, so we have those 3 there, and we could just add 9 over 64 plus 9 over 64 plus 9 over 64, which ends up being 27 out of 64, and if we divide 27 divided by 64, guess what it comes out to be? Same thing that we got doing this the other way. So that's just one other possible way to do it. It's not a bad way if you're only doing something like this. This isn't real long, but you get any more than that and the tree diagram gets huge and probably not the best way to do anything. Alright, did that. The results of, flip past my page. The results of a certain survey indicate that 67% of U.S. adults consider air conditioning a necessity. If 100 adults are randomly selected, what is the probability? Exactly 75 consider it a necessity. What's our N this time? What's our P? What's our Q? I'm not sure why I switched them around this time. It doesn't matter. What's our X? How many do we want? So C, 100, we want 75 times 0.67, and we take 100 minus 75, what's 100, or no, we don't, sorry. We just put 75 up there, right? Then on the next one we do 0.33, what's 100 minus 75? 25. Type that into your calculator.
0.0201.
So we'll say about that. So what's the probability that we go out and we ask 100 people and exactly 75 of them say that air conditioning is a necessity? About 2%.
That number should be a little higher.
Now, remember, you're saying exactly 75. So is that considering 76 people saying it's a necessity. 74 people, so it's just exactly 75, about 2%. So if we went through, and if we made our little chart here, where we have our X and our probability, what are our possible outcomes? How many people could we have say yes?
1 through 100.
Or 0 through 100.
0, 1, 2, 3, 4, 5, 6. Is this something that we really want to do in this chart? Probably.
No.
Probably not.
Maybe I won't do that.
Because we're going to have to find each one of those probabilities. Now you will have to find the probabilities, but hopefully we'll have something that, little easier ways to do it. Sorry. On this, I'm trying to see if I want you to write any of this or if it really matters. What I put on this page. On this chart, this is just the chart for the knee surgery thing that we did a few minutes ago. If we listed it all out this way, again, these charts, I'm going to make mine up and down more times than not. This book switches back and forth. Sometimes it makes them up and down, sometimes it makes them sideways. If we're looking at this, if we wanted the probability that the doctor has 2 or 3 successes, then we could just add those two. If we want the probability that the doctor has no failures, what would we do? There's a couple different ways we could do it. Subtract what?
Wait, for no failures? You should subtract 3 or 3 more.
So probability, no failures. Which of these events have no failures?
3.
This one? Be careful.
That's the last one, 3.
Just that one, right? So what's the probability they have no failures?
42%.
42%. What's the probability, so you gotta be able to read these problems carefully and understand what they're asking you. What's the probability the doctor at least has 1 success for the day? What would we do to find that?
Add up 1, 2, 3.
Add up all 3 of those, all right? And that's where these charts are gonna come in handy, because then we can just add them up to find when they ask us some silly questions like more than 5 or less than 6 or whatever. In a survey, workers in the U.S. were asked to name their expected sources of retirement income. 7 workers who participated in the survey are randomly selected and asked where they expect to, whether they expect to rely on Social Security for retirement income. Create a binomial probability distribution for the number of workers who respond yes. So look in there. Does anybody see Social Security?
Yeah, 25.
What's it say? So what's our P?
25.
0.25. What's our Q? 0.75. What's our N? How many are we asking? 7. And we don't want our X. We want them all. All right, we want 0, 1, 2, 3, 4, 5, 6, 7. So we want to make this chart, and I think I have this on the next slide here. Get your calculators out because you're going to help me. So this is our X. This is our probability of X. What are our possible X's? 0.
1, 2, 3, 4, 5, 6, 7.
Now our formula, again, it's this formula. That's supposed to be an N there. My pen doesn't want to write. P to the X power times Q to the N minus X power So grab your calculators and we'll do one of them together, then some of you do like the middle one, some of you do the bottom, some of you do the top ones, whatever, so that we can get it done quicker. For 0, let's do something different. Which one you wanna do?
1.
1? So for 1, what goes in place of x right here?
Wait, it should be,
1.
it should be n before x, and then.
I'm really backwards there, my fault. What goes in place of n right here?
7.
7. What goes in place of x?
1.
1. P is
0.25.
0.25, x is
1.
1, Q is 0.75, n minus x,
6.
6. Do all that, what do you come up with?
31.311.
0.311?
Wait, that's a 0.
Oops. Anybody else agree with that? Is that right? So try the rest of them. Go ahead and on your calculators there, I'll give you a minute or two. Some of you do 2 and 3, some of you do 7, 6, so on and so on. But try them.
I got it.
Write them down somewhere so you know them, and then we'll stick them up there. Look, Gage, it must be the seat that causes people to just fall asleep. Is that what it is? Jackie, it's that seat? Bought me a gallon of water, so.
There we go. I should probably do that. You crack the seal on it?
Should've got the new cup.
What college did
Why,
we
you
go
wanna
to?
buy it?
Yeah.
Wright State Rock School.
4.058.
Oh wait, zero's supposed to be really small.
No,
It's supposed to be really small.
Quit cheating. No, it's still not easy, but you still gotta do stuff like this.
Like scientific, it's like scientific notation, it's not
Right, you
negative
can
5.
punch them down, but it's not really that many
6.10
separate buttons to
zero
punch in
six.
using the calculator steps.
Yeah.
I know it's about the same button, and plus when we do stuff like, what's the chances of getting 2 to 5?
Pretty good odds.
Anybody get any of them yet?
Yeah. 7.
7 is what?
0.0000061.
How many zeros? 5?
5.
6, 1?
Yeah.
What's the 6, I suppose? Anybody get any others?
I got 2.
What's 5?
5 is 0.011. 012.
2 is what?
0.011 or 0.012.
Same thing?
I got 4.
And then 0 is the same as 7.
0 is the same as 7?
There's a pattern here. I'm gonna guess 6
4.
is probably like 0.311.
4 is what?
0.058.
It's 3.058.
I don't know.
Anybody do 6 or 3 yet?
I can do
6
6.
probably.
I hear you say probably, but grab your calculator
This
there.
is probability.
It takes about 10 seconds to punch it in to make sure.
6 is 001.
That's not the same.
My fault.
At least we didn't listen to Gage.
Hey, Sean said the same thing too. If you're gonna go out on a limb and say 3 is
3 is the
0.058.
same though.
See?
Alright, good
Hey,
job,
you should listen to
Gage,
me.
wow.
3 is the same as that? Is that what you're telling me?
Yeah.
Then maybe, let's check this one again, is it?
So it's.
Or check, maybe we need to check, 2. Cause it looks like that they match up all the same. I'm hoping unless you guys are just guessing and telling me that.
Be 6. Wait. No, 7. C6. I got.
Calculator works the same.
I got point 3.
What do you got?
6.
You got what?
Point 311.
For 6?
311?
I got 0.001.
5.
So let's write 6 up here just to make sure we're doing it right. Sixes,
I got three.
we got
Dude,
seven,
dude, do the-
6,
Let me check,
Yeah,
let me type it in right again.
point 25
Seven CR
to the 6 times
times 0.25.
point 7 to the,
Oh, 0.75 first?
I got two's different.
Yeah, twos.
is this the way it should be punched in for 6, right?
Yeah.
I've been doing it wrong the whole time.
Is that the way it should be punched in for 6?
Did you do number two?
I got the P's and the Q's mixed up.
So are we wrong some places?
Yeah.
Two's 0.311.
Is it huge?
It is.
Nice one.
Is that right?
Yeah, it's dramatic.
Yeah.
Where else are we wrong?
Oh.
Or, I don't know.
Do they add up to one?
They should all add up to 1. We'll find out here in a minute, if we ever get them all somewhere where we're
Well, I
in
don't know
agreement.
if they do or not. 'Cause they don't look like they will.
So we're probably way off somewhere.
Yeah.
Yeah, cause right now it looks like they add up to about 0.8.
Zero.
Zero's wrong?
Yeah.
What's it? 0.133?
We don't even get close. Man, you know, if you flip the P's and the Q's, you get the wrong answer.
About 3, is 3 right?
I'm checking.
I got 0.173 for 3.
It's 4 right then?
I don't know.
Cause I
Four's
did
right.
4.
4's right?
Been scared. I know mine's right.
Mine's right.
So
It should be
are
right.
we wrong on 3?
Let me check.
What'd you say, Michael?
I got 0.173, but.
Wait, let me try it.
0.173?
I got
7.
0.173, is that what we're going with?
Yeah.
I got 0.173 too.
4's right now?
Yeah.
Is that-
And so is 3. 3's right.
3's right now? 4's,
I think we're good.
5, anybody try 5 to make sure?
Yep.
If somebody's got a different answer, yell out because,
I checked 5. I got 5.
Yeah, 5's right.
alright, 6 is right, 7's right, we're going with all those?
I didn't do
You sure?
6 I did. Okay.
This,
so
what we have right now adds up to .999.
So that's pretty good.
Well, so mine's like point.
Now, hopefully it's pretty good, I mean, we could've messed up like 4 of them and still get .99.
Well, you took off the 1 on the last one. There's a 0.6. It was 0.61. So that would make it 1.
I'm getting ready to throw something.
Throw it.
He's not listening to what I say, I'm saying. We could have, Phoenix, what I just said is, we could have the wrong numbers for all of these and still get this answer, because maybe this one's too high by a certain amount, and this one's too low by the same
But
amount.
what's the probability of
Yeah,
that?
that might not be a very good probability, but. So, you do all of this, you make this chart, plug it into your calculator there, and Brendan's up here already saying, oh, I can do it easier, because there is a way to do it on the calculator, but there's not a way to do, something like the probability that between 2 and 5 are successes. Alright? So you have to be able to make the chart, and you have to be able to go through and do this stuff so that you can add them all up. Now there are some ways that we're going to try to figure out that might make some of them a little easier, because if we have, like on this one, if we have 100 different things, we probably don't want to make the whole chart. I'm thinking maybe we are going to make the whole chart. That's getting on my nerves.
How's that feel when you're already
Does that look like what we had?
Yeah.
Yeah.
Whoa, the last one, no.
Yeah, the last one doesn't it? It only goes out 3 zeros instead of.
I put in all the numbers right.
That was you. Did you
And
put to the
I did
last
not
one?
put to the 0th power
That's
on that one right there. That
Did-
0.7, but I did not put 0.
Did you put .75 there?
Yeah.
Because what is .75 to 0 power?
Well,
It's
I
just
didn't
one,
I didn't
so
put 0 there, so.
Well, if you just left it off completely.
And I didn't leave it off completely. I put 7 in
The
there.
calculator, I was reading 0.2 or 0.6.
Bro.
Yeah, it was e to the -6 or e to the -5. You need the steps.
Nah, I just gotta remember the formula. Make sure I don't punch it in wrong. So it's 7 probability, and then taking 7 at a time. Why'd I do that? What is 7C7? 1. I don't know, I just punched that in my calculator like an idiot. So times that by 0.25 raised to the 7th power. Yeah, that is what it gives us. Oh, they rounded it up. They only went out 4 places, even though Phoenix did tell me wrong still, because he told me 5 zeros,
It's at the.
and there was
That
only.
doesn't make it 5 zeros.
It does, I said 5 zeros. You said
Yeah,
five
makes it
zeros.
4.
There's 5 zeros.
Don't count to 0. What'd I tell you about that 0?
No,
It still makes it 4 zeros. So that has 4 zeros, so
5
you're adding
zeros.
1 before the decimal.
It's 5 zeros.
I'm gonna write this up here, because.
My bad, guys.
Hey, man, you're talking probability and they're still adding up.
Phoenix, if it looks like this,
Yeah.
you bump it
Phoenix got
over,
wrong, it's
you
still
bump it
there.
over one
That's
place
right.
for the 6, and then how many zeros do we have to add after that?
Yeah, but Phoenix, they rounded it, Phoenix did.
He
That's
only,
right.
he doesn't wanna say it out loud, does he? So our chart looks something like that. When I added all these up, I came up with that. We came up with something a little lower because we rounded just to 3 places instead of 4. A survey indicates that 41% of women in the U.S. consider reading their favorite leisure time activity. You randomly select 4 U.S. women and ask them if reading is their favorite leisure time activity. Find the probability of at least 2 of them respond yes. If it says probability at least 2, what probabilities are we finding?
2, 3, 4, 2,
2 plus probability of 3 plus a probability of 4. So we'd have to make our chart and then add up those 3. N is 4, P is 0.14, Q is 0.59, and our X is 2, 3, and 4 this time. Looks something like that. We just find each one, then add those 3 up, and it comes up to about 0.542, or about 54%. I'm gonna sort of skip through this one so we can get to something else here. Again, be able to make a histogram. On the side over here, you're just gonna have your probability. On the bottom is your X's. Most of these, they're not gonna be, I'm not gonna give you 100 and say make a chart. All right, that's not gonna happen. There'll be 6, 7, maybe 8 at the very most. Write this down. This is for the new calculators. I don't know, Riley, if you guys, or some of you, Brian, on your calculator, you might, when we try to punch this in here in a minute, see how it works out. Now, the stuff in red here, you're gonna hit second, then you're gonna hit the DISTR button on your calculator, which is, the second for that button is the variables, the vars button. Then once it's on that next screen, you're gonna go to 0. I think most of the calculators are 0. Some of them, they change them up. This is where they change some of them. I think it's 0, but it should say binom PDF. Binom PDF. And it's gonna pop this up on your screen, I think. And then, again, I'm saying I think because some of the calculators are different. It's gonna pop this up on your screen, and then it wants you to put in N, P, and X. How come it doesn't want you to put in Q?
Because it already knows it.
It can figure it out once it from P. It's smart enough that it figures it out on its own.
What is step 5?
Yeah, what is parenthesis?
Just close the parenthesis.
Okay.
Oh, binomial.
Was it ours, was the black button, or the black, written in black supposed to be like,
That's what, so like this part is
Yeah.
what it's gonna say. The bars is what's actually
so
above
which
or
one are we
below.
wanting to use?
We're gonna hit second, then that button, which gives us this.
Because ours is, like if you have the TI-83, ours is the button, not the second.
District.
Oh, okay, so we want this then, so I got it backwards. So we want this, but bars is what the button says.
Yeah.
My fault.
Or is it's A? Yeah, it's A.
Is, what's A?
Instead of 0, it's A.
Instead of 0, this is A. You sure? Binom PDF?
Yeah.
Is
there any of them that's 0 still, or do I need to
There's
switch
one
it?
that's 0.
Wait, how do you do it?
Some of the calculators still say 0.
7.79.
I need my calculator.
How does it give us that? 4. N. Then we click enter. And it's 0.126.
Stupid thing.
Wait, if I hit 0, it gives me the binom PDF.
0 says binom PDF, so yours
Yeah, like if I hit 0.
But if I hit 0, my thing takes me to some.
So just know which one we want. Binom PDF. Everybody understand that? Because it's different on a whole bunch of the calculators. That's what we're looking for. Binom PDF. So if we go back to the one that we just got done doing. Let's see, let's make X. Does anybody remember any of the X's on that problem that we just had all messed up?
1 through 7, or 0 through 7.
That was it, right, but anybody remember any of them, what they were?
Point, I didn't write it out.
What was
0.058.
0.012?
I know 7 was,
0.1.
Well, it was 0, 0, 0, 6.
4 zeros and
6. They had 3. They had 3 zeros and a 1 because they rounded up.
Right, they rounded up, so let's go with that.
Okay.
Just to check and make sure that we can do this. So in our calculators, we're gonna hit second. And then, see, mine's the bars button. Yeah, that's what you said, isn't it? Second, then that, and then we go to normal PDF, which on mine is, see on mine, or not normal PDF, sorry. Binomial, we scroll down to binomial PDF, on mine it's
If I just hit the 0 key,
then yours goes
then
right
it
to
takes
it.
the binom
Okay,
PDF.
as long as you know that, as long as you know how to do it on your
It's
calculator.
on there, but
We hit,
0
It's on
takes you
there?
there. Yeah, if you go past 9.
I didn't know it could scroll down.
we hit enter, and mine pops up this, binom PDF, and it's got a parenthesis, and in that parenthesis, we want N, comma, P, comma, X, comma, or we don't need a comma after X, close the parenthesis. So N this time is 7, then we gotta hit the comma button. P is 0.25, hit the comma button, and X is 7 again, close the parenthesis. You probably really don't have to close the parenthesis, but I always do, just in case.
Yeah, that should give us the same answer.
And what's it give you?
6.1.
Times 10 to the negative fifth. Is everybody getting that on their calculator?
Well,
Now, this down here, PDF, you might want to put this somewhere in your notes there. PDF just gives us the answer for one certain set of outcomes. Like here we wanted for 7, we could have done 6 or 5 or 4. CDF, which if I do second, the bars button again, and I go down to, on your guys' it's B, on mine it's A. If I go down to binom CDF, it does something different. So let's do this. Let's punch in, go to binom CDF, hit enter. And now let's put in these numbers. So for N, we put in 7, comma. For P, we put in 0.25, comma. And for X, we put in 7. Bet it tells you that, doesn't it? And the reason, CDF, what CDF stands for, or what C stands for, is cumulative. What's that mean when we're saying cumulative?
Total.
Total, you're adding them all up to that certain point. So if I go back here to that problem that we were doing,
oh, so that can,
So you just do it too.
so if I went back to, and I would hope that you don't have to do this for 7 like we just did. If I went back here, what we're finding out when we're using CDF is what all the probabilities from 7 down total up to. Alright, well what should all the probabilities from 7 down total up to? 1 whole. Alright? So if we wanted, say we wanted to find the probability that our X is less than or equal to 5. Instead of having to find all these and add all these up, we could just use CDF on the calculator. Does that make sense? Now the bad thing is, if they say, what's the probability that you get 2, 3, or 4, like that one problem about the women reading books, is that going to help us here? No, because CDF is going to tell us from 4 all the way down. So what we could do, if we're looking for a probability that you get 2, 3, or 4, is you could find the probability from 4 down, and then subtract off the probability from 1 down, using the CDF instead of PDF. Does that make sense? Not really. I'll go back and try to go over it a little bit more. So on this, the CDF we use if we want more than just one. We can use the CDF to help us find that. If we just want one, then we use the PDF part. Alright? Let's see if we got one on here. Did your guys', Riley, did yours have it that way? Was it something, Brian, was yours that way?
Yeah, that's fine.
Yours is that way? Yours
mine
isn't?
is very different.
Yours is completely different
Yeah.
from both of them?
I don't even know if I got the right answer.
So on this one, it says, find the probability that at least 2 of them respond yes, that's their favorite. That's not what I wanted to do. So this is for the women again. We could make this chart. At least 2 of the women. How many women do we have? 4? Is that right? Yeah. So let's do this real quick. We got just a few minutes here. Try to get this whole chart. We could have, how many women say yes? 0. How many? 1, 2, 3, 4. Let's find each of these probabilities using the PDF button. So grab your calculators and help me out. I'll do 0.
I'll do 1.
You guys figure out what everybody else is doing. Oh, we should probably write down N is 4, X is whatever you're putting in, P is 0.41. Those are the 3 things that we need. I just had to make sure I was putting them in the right order, because in the parentheses it goes N, P, X, right?
Yeah.
Isn't that what it says?
Yeah.
Have to make sure I'm putting it in right. And I'm doing 0.
1 is 0.337.
Anybody else get any rest?
3 is 0.163.
2 is 0.351.
Anybody got?
0.28.
Point what?
0.28.
Now we could check it, let's see, at 0.3, 0.7, 0.8, 0.9, it looks like it probably comes up pretty close to 1. Alright, so I'm hoping that we're alright. Now, if we want the probability, and we just use the PDF for all those, if we want the probability that we get 3 or less women, then we can use the CDF button. Somebody, while I'm punching this in, see these 4 right here?
Yeah.
Add them up for me. And I'll use the CDF button. Some of the rest of you can try to use the CDF button too, to make sure that I get the right thing.
Do you want me to say it?
No, not yet. Let's see. 3 N's, 4, comma, 0.41, comma, 3. I got this, Ben.
Yeah, that's what I got.
So if you add up these 4,
Yeah.
you get that. So using the CDF button just takes this probability plus this probability plus this one plus this one and adds them all up. If we wanted to find what this one says at least 2 of them respond yes. So at least 2 means 2, 3, or 4. So we could just, now that we have this chart, we could just add those 3 up, and that would give us our answer. The other thing that we could do is we could take the probability using the CDF, probability of all of them, and subtract off, which the probability of all of them is just going to be 1, and subtract off from 1 down, probability of 1 and 0 going down, using the CDF button. So if I do second bars, I gotta get a new calculator. CDF, and I punch in, this time I want N is 4, P is 0.41, X is, we want from 1 down, so we're just doing 1 and 0 together.
So, 1, do you do 1 comma 0 or?
No, We just do it this way.
Okay,
He's using the C.
Using the CDF.
okay.
Yeah.
Alright, so 4, comma, 0.41, comma, 1, close the parenthesis, and I come up with 0.458. Anybody else get that?
That's what I got, 5.
That's these two added together.
How you subtract that from one?
Subtract that from 1, and that's gonna tell us what was left for all of this going this direction. And it should be something like 0.542.
Yeah.
So, using that, you figure it out, make it the easiest, or do it the easiest possible way that you can for yourself on each one of them. We talked about these earlier this year, but we didn't talk about this. The bottom part here. If your probability, the probability that you're dealing with, if it's 0.5 or higher, then it's always going to be skewed left. It's going to have a tail out to the left. So this is, for skewed left, this is if the probability is greater than 0.5. If the probability is less than 0.5, then it's going to have tail out to the right when you draw your histogram. If the probability is exactly 0.5, then it's going to be symmetric. Anybody have a guess when it's uniform?
When it's I don't know.
No. I just put that one up there because all four of them go together, right? Plus that's the one that I always forget about, so I put it on there so that I could remember the name again, so that Brendan didn't have to tell me this time. So if you had to draw the histogram, or if you're looking at a histogram, you can tell, if I give you a histogram that looks like this, you can tell me that the probability has to be greater than 0.5. If it looks like this, where it's symmetric, then the probability is equal to 0.5. Last thing here, these are those formulas I said I wanted to make sure we got to. To find the mean, standard deviation, and variance. You could do all the stuff, punch it into the calculator, just like we did in the last section, to find it. But for a binomial, it's a little easier. For a binomial, this is the formula for the mean. This is the formula for the variance, and this is the formula for the standard deviation. If it's binomial, this only works for binomials. So the way this is, all binomials are probability distributions. So all of them are the same as what we covered in the first section in this chapter. But not all probability distributions are binomials. So this works just for binomials. The stuff that we did the first section works for everything. So if Zoe doesn't remember any of these, could she go back to what we did and use a calculator, find the variance and standard deviation and stuff using those formulas from last class? Yeah. But if it's a binomial, then this is a little easier, because all this says, mean is just n times p. So for the women that we just got done doing, that n was 4, p was 0.41. All you do is multiply those two, and that gives you the mean. For the variance, it'd be 4 times 0.41 times q, which is 0.59. And then to find the standard deviation, what do you do to the variance? take the square root of it. Now it'll give you the standard deviation. Again, down here, I tell you, you get on the test, when we take a test over this chapter, you get on the test and you think, oh crap, I don't remember what a binomial is. Do you have to remember what a binomial is to find these? No, you can use the formulas from the first stuff and do the same thing. The bad thing is, for the first stuff, you have to put in your list 1 and your list 2 and do all that for it. And that means you'd have to make that big chart, however big it is. Pittsburgh, Pennsylvania, about 56% of the days in a year are cloudy. Find the mean variance standard deviation for the number of cloudy days during the month of June. Interpret your results. What's our N this time? It's June 30, is that right?
30.
Yeah, 30.
No, you know that little trick? My wife always does it.
How do you do it?
More, I don't know.
It's like, it's supposed to be like every other month, but it's just not every.
It's not every other month. She does something else.
I'm like, you're not.
She goes like January, February, March, April, May, and as she's counting them off, I don't know, she's doing something with her fingers. I never learned it. Somebody look up real quick, how many months or days?
30, there's 30 in June, I was right.
30, all right.
Come on now, I know my months.
So N is 30?
Because he was making me think I didn't know.
I didn't know. I was asking to make sure. Nobody else wanted to type in. What's P this time? 0.56. What's Q? 0.44. Our X, we're not sure what it is, and we really don't care what it is because we're just trying to find the mean, variance, standard deviation. Mean.
16.8.
Mean, you take 0.56 times N. What is it?
16.8.
So what's that telling us? If we live in Pittsburgh,
It's gonna rain for 16 days in June.
it's gonna be cloudy about 16 or 17 days in the month of June. That's normal. The variance, what do we take? We take that 16.8 and we multiply it by what? 0.44. Somebody do that for us.
7.392.
And then to find the standard deviation, what do we do?
Find the square root.
Take the square root of 7.3, what's that give you?
2.7.
So if we were gonna look at our normal curve, what'd we say about in between two standard deviations from the mean? 99.7% of everything should fall, or should fall in that range. So most of them are gonna fall in there, and we could say, okay, then double that, that's about 5.4. So 5.4, it's always gonna, it's probably most of the time gonna be between 10 days and 22 days of cloudiness in Pittsburgh in June. 16.8, is that what we got? 0.7. See being the northern zone. That's the assignment.